Open a chat window. Chat window. Open in browser. Go back to Restream. Restreamio. And oh, look at you. Twitch is not working? Nope, Twitch is working. Turn on the sound and hear what my volume is like. Oh, look at you. Twitch is not working. Sound is okay. Okay, over here back on chat, chitter chatter, nobody here. That's good. It's sometimes easier to deliver the show when there's nobody here because especially today, I had a bit of a rough day. So here we go. But this is an exciting week. Let's see what we have to talk about this week. Partial boundaries, layer boundaries, and something called the main component. And I think part of what's exciting about this week is that it is kind of on the short side. Oh, somebody's arrived on Facebook. Somebody's on Facebook. Hi there, Facebook. So let's see. I bet you. Anyway. Oh, no, somebody left Facebook. That's fine. Facebook is not my number one place. Anyways. So in talking about, I wonder if I should do this with the notes up or not. Nobody's here. We'll do it with the notes off. Not on the screen. So, no, maybe I'll bring them up. We'll see. We'll see how it goes. So, the first thing that we want to talk about in reference to partial boundaries is we want to start by laying the foundation that everything we talked about in the previous weeks in dealing with hard boundaries and strict separation of concerns winds up being incredibly expensive from a production and development point of view. And so the author has come along and said that, well, what if we start working on these things that we call partial boundaries? And to that extent, we're saying we are not doing this full rigorous separation of concerns, but we are moving things apart just a little bit. And he provides a number of techniques for dealing with what we call partial boundaries. So to that end, so we've said architectural boundaries are quite expensive. Now, they take a lot of work now when we are building them. And the payoff definitely doesn't happen till later, but here's one of the other interesting things about that payoff, especially if you've listened to some of the other goals of architecture, which is to defer all decisions that you can possibly defer until later in the project life cycle. They might never happen at all. So he gives the story of one of the systems he built once where they said on day one of the project, oh, we're going to need a database, we're going to need a MySQL database. And they build this system and they don't want to do the database right now, so they defer the decision and they start working with just standard an in-memory database. And they got a whole bunch of stuff written for that in-memory database. And then they said, well, we still don't want to do the MySQL, but we do have to work on the persistence. We've got to work on save and load. And we need to do that between restarts. So they said, oh, let's just write a file system database. And then they did that and they proceeded. And by the time they were ready to go live with version 1.0, there was no need for a database. They said version 1.0 works. The system is separated is appropriately separated, but who cares? We don't need to do this last step. And that's what we're talking about in terms of the world of doing a full boundary. If they had done a full boundary from the start and separated things, then they would have invested all of this time, energy, complexity, and money in building something that they didn't actually need in the long run. So that's to say, one of the things we can do is work on something called a partial boundary. Again, so we separate things out as far as we can possibly get them, but we stop short of creating a rigorous and hard split between them. So I'm going to switch to the text mode so that you can follow along in the notes here. And we've got a few things that we can work from. So he provides us with, sorry, I hope I didn't bonk you in the sound department there. He provides us with three major options for working with this skip the last step formula. Or sorry, the partial boundaries. Partial boundaries can be one, skip the last step. Two, it can be a one-dimensional boundary. Or three, it could be the use of a facade, which is a well-known design pattern we could look up and talk about later. We've talked about facades in a previous episode, so if you are following along, I don't have to repeat it. And if you show up and say something in chat, then we can talk about it in real time. So let's first focus on this sort of skip the last step one, and that's if you've got a system that you're designing, maybe it's a web system, whatever, it's not really relevant exactly which, you could go so far as you build your interfaces. You could build your, sorry, I'm just going to mute this guy. Do not disturb. There we go. So you build your interfaces, you build your, what else? Your actually bidirectional interfaces. You ensure that you have you make sure that you have an acyclic dependency graph, right? Is that what it, or acyclic directed graph or directed acyclic graph? Doesn't matter. DAG, and stopping short of actually moving these files out into separate projects where each of them deploys onto its own infrastructure, you instead just leave it there, sort of encapsulated within a single program or component, but you don't actually move them apart and split them and do that last level of work. Now, the upside of doing that is obviously things are still connected and together, and you don't have to worry about things like orchestration of your various now separately hosted services. You don't have to worry about what do you do when one of them goes down and the other one's still up and they're trying to communicate and they can't. You don't have to worry about you know that they deploy together and all of these things. So it's really nice that you're saving quite a bit of money and time and complexity, but you always know that you could split these apart and send them off in separate channels at some point in the future. Now, again, and the warning that is up on the screen in my notes right there is be careful when you are doing this, though, because unless you monitor those systems quite closely, you're over time they're going to start to, maybe you get a junior developer and they say, oh, well, why don't I just reference this thing directly? It's a lot easier that way. And your code can sort of like zipper in together, and the things can cross boundaries in ways that they shouldn't. So you've got to watch that within your code. You've got to watch for that within code reviews. Hopefully you see it. You've got to just keep an eye on it to make sure things aren't happening. You might do that yourself when you're not paying attention or you're feeling a little lazy one day. So the upside is you save complexity. The downside is you may suffer entropy, where things eventually become inseparable because you've failed to continue to pay attention to that, or maybe you've deprioritized. And here's the thing: if you deprioritize that and make that as a conscious choice, it doesn't matter. That's okay too. So here's the next thing that can happen, and we've talked about these. We've talked about our sort of directed acyclic graphs, our one-way flow charts, and let me bring up the image from last week so that we can. So this idea of one-dimensional boundaries says sort of the outer rings depend on the inner rings, but you don't worry about making it a two-way separation. So I'm going to load up last week's discussion, the week 10 stuff, because I have a diagram in there of this stuff. And this is what we're talking about in terms of our rings. We've got our boundaries, we've got our layers, and perhaps when we're designing these things in an extremely rigorous situation, we would say our entities publish interfaces that go outwards, and also our lower level things are publishing interfaces that we pass inwards, and so what we have is sort of a bi-directional decoupling, right? So a very strong decoupling is one where gateways, your gateways, for example, are completely standalone, where they do not reference outwards and they do not reference inwards, and everything is just through these sorts of API contracts and interface contracts between the layers and between the systems, even around within their own ring. Now, that again is the expensive version of doing this. So one of the things that you could do to offset the complexity and the cost of what you're about to embark on is you could just make these things one directional. So maybe your gateway does reference the entities directly or does reference the next layer up directly. It's important to make sure that your dependencies only point inward, so your highest level stuff is properly separated and isolated, or maybe things reference each other more directly within the same layer. So I'll bring this image back up and we'll talk about it there. So, that's that was the wrong page. What am I looking for? Desktop. Here we go. So, like maybe your presenters and your gateways within that layer kind of talk to each other a little more directly. That's maybe not as big a deal as separate. Anyways, so what we're talking about there in terms of saving on complexity and the challenge of dealing with this, it's called a partial boundary. The final one, which we have talked about once before in a previous class, and it is a very well, look at my hair. Oh goodness me. Thank God we are not watching me for my hair or my modeling ability, because that was big sticky uppy piece. Anyways, that's so we've talked about facades in a previous round, in a previous lesson. They are in fact, we even talked about them in the code interview study group. So we've dealt with facades a couple of times before, and in this one we're going to reiterate that what you have in a facade is you have a single class that loads all of the other classes, and so that's sort of a fake boundary. It's not a real thing, but what you have is this separation of concerns between your outer layer stuff, or the thing that loads your facade has a separation where it doesn't have to work with the minutia of the system as a whole. Now, the caveat or the warning around what could happen if you start working in a facade system is something called the transitive dependency. So because your facade now depends on subclass A and subclass B and subclass C, in theory, anything that happens in the class that loads your facade also depends on all of those things by what's called the transitive property. And we could go and look up the definition. I think based on context, it's sort of the property transits through the facade. Now, important to also counterbalance that with the fact that actually, if your facade class loads up a whole bunch of doohickeys a whole bunch of things. And in terms of your testing or anything like that, you don't really need B. You don't need subclass B. You could stub out subclass B and just sort of not really pass in a null, but you could pass in something that doesn't get referenced, and and so to some extent there is some play there, but you still have to worry about it. It's still a consideration and a concern. So the conclusion for this chapter around partial boundaries is that, first of all, part of our job as architects is deciding what will probably need to be separated one day. And it's important to consider this while designing the system for the first time, but also keep an eye on it, because as an organization grows, as a project grows, as we add new features and systems, some things that used to not need to be separated will in future need to be split apart. So that's chapter 24. And how did we do? 30 minutes? No, I started late. How long have I been streaming so far? I wish I had that stat. Oh, here it is. So 15 minutes. That's okay for chapter 24. Now, the next one that we're talking about is called Layers and Boundaries. And I don't really want to go through. It's actually a really compelling individual case study, not really a case study, but sort of an example in the scope of, he takes a 200 line of code video game, just a text-based interface that sort of, if you remember games like Zork, Return to Zork, or some sort of text-based dungeon crawler. This is the sort of thing that we're talking about. Very simple stuff from like the mid to late 60s. Super simple, kind of cool stuff. I mean, from a historical perspective, they're kind of cool. And what was really nice about this chapter, in taking something such a simple system, he goes through, and now one of the things I should also say, I'm almost kicking myself right now for not going through and replicating his diagrams for this, because it on reflection is a pretty good chapter overall, but it doesn't tell us anything that is particularly new. And in the interests of respecting your time, the viewer, I don't want to go into repeating something that he just said 2 chapters ago and 4 chapters ago and 6 chapters ago. So but it's a great version of the example that he's done 4 times already. And so what he talks about is, he says, think about, for example, so you've got this text adventure where you can say east, and the text adventure says you are now east, and you say, okay, north, and it just goes through it. And he says, well, what if we wanted to break that into 2 different languages? What if we wanted Spanish and English? Well, if you wrote an interface for the message that gets sent, then you could break that out into 2 pieces, right? English and Spanish, and they would both inherit from an I language controls. And then he says, well, what if we wanted to add a network or desktop display layer, and so all of a sudden you break off the display piece, but you're retaining the same gaming. So your languages point into the gaming rules, and then your display piece points into the gaming rules to find out what to display, but it might go off to a desktop app or a web app or something. And these are all things that we've already talked about. But so I'm going to skip straight to the conclusion on this chapter, and that took 3 minutes to talk about. So I don't think I wasted any more time than it deserved. So here are the conclusions. He says, sort of, as architects of our systems, we have to carefully recognize when we have to split these things apart and where the layers might be needed. So maybe we've got, maybe we've got the network layer. Anyways, the next one, every time we draw the boundaries, the system gets more expensive to work with, right? It becomes more complex. It takes more people to do it because it takes more lines of code to send a message back and forth from one way to another. We just need to do more work to separate things out. And so back to the fundamental principle that we were talking about in chapter 1 or 2 or something. The goal of architecture is to delay all decisions that don't have to be made until they absolutely have to be made. So again, it's about monitoring things, knowing, and it's about watching things, and it's about not jumping too soon, but also putting in just enough effort so that you are not painted into a corner as well, if that makes sense. It's a balancing act, and that's part of the art that goes into the art and science of programming, because we really do have to feel things. We have to make a lot of guesses. Hopefully they are educated guesses. If we have more context around the systems that we're building at any given time, we will be better equipped to make better decisions. And those are all the things that we have to put together as considerations on this front. But anyways, so the point is, it gets expensive. Over engineer. Oh, here's another conclusion. Over engineering something is often something far worse than under engineering it. I'm not sure how true that is, but I guess there you go. So I think that's, if we are going to make an error, it's on the side. It should be on the side of under engineering and not committing to these major plans too early. Again, pay attention to the system as it evolves and be ready to make changes. Note where the boundaries may be required. And here it is. Here it is again, just what we're talking about. I mean, he says it in a different way, and so I'm paraphrasing, but he says, just only add them at the exact perfect time, right? Don't add them to the Goldilocks zone, right? Just not too early, not too late, just at the exact time. And what is the right time? From a definition perspective, it's to say when the cost of implementing the new boundaries becomes less than the cost of ignoring them, right? So you've got this big chunk of work, so you ignore the work for, and your work just ticks along. It goes doom, 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 doom. Everything's fine. And it's sort of, the cost kind of scales up. It gets a little more expensive to make your change, a little more expensive. And there's some sort of inflection point where the cost of, so if the cost of implementing is here, over time, as complexity grows, you go, bam, okay, so the cost and the cost of each additional change, or the next feature is here. So let's implement the change. And so your progress sort of stalls as you go across to separate this stuff, but then it shoots back up, and maybe your growth curve levels off again in terms of cost and complexity and all of that. And how do you know when that sort of magical point happens? You guess correctly. That's it. It's just, this is the core of the job, is being educated and prepared and knowing what's going on and thinking about this stuff and hopefully getting it right. So it's just, that's the story. That's the story of, and that's the chapter, layers and boundaries. It was really more of a case study than anything else. So now we're on to chapter 26, and our stream time is 24 minutes, and yeah, we're making really good pace. That's good. So we will be done in probably less than 45 if we go. So This one I'm gonna bring up the notes again for a second just to see. The main component. Every system has a main component, and let me bring up my VS Code, hopefully on another screen because I don't know what's in there right now. File, new file. Oh, yeah, I'm writing some fun stuff. I actually don't want that on screen right now. Okay, so let me. I'm just sorry. You'll have to indulge me. Am I going to do this or am I going to skip it? Let me see. There's one person watching. Do you feel like I'm wasting your time? I guess not. If you're here, I'm probably not wasting your time. I don't want to. But anyways, so just give me a second. We're going to do something here. So new example live code. Going to open this one in Visual Studio Code. And so here we go. So let's go Control Tab. Zoom this up enough that we don't show my get started. So just going to do something like this. I'm going to say .NET new console, and I get a brand new console app. And I look at the console app, and we have this thing here called static void main, and it takes a string array called arguments. Now, what is important to note about this is that .NET is not unique in this regard, in that it has a I believe Java has one, and I know Java has one, but I believe it is also called main. And the entry point, if you're working on a Node.js program, is going to be the index file that you load, or just the name of the file. But for all intents and purposes, the name of the file where you start the program is main. And here, we'll turn this off. We don't need this. So the name of the file where you start the program is main. But again, if we're looking at a JavaScript, you might have your requires, you might have your includes, you might have all of that stuff. And so your main is the thing that decides what else gets loaded. So every single system, this is really important, really key for understanding any system, no matter what system you land on, what language, platform, or framework you work on, every system has an entry point. And just for shorthand, just for sake of argument or for ease of understanding, we can refer to that as main, despite it being a file or a different function name in a different language or whatever. We'll just call it main for what it's worth. Now, the main component is the ultimate detail. And you have to go back to the early chapters of the book to remember that we separate all of our architectures into, effectively, we separate everything into business rules and details, right? So the business rules, recall, are the core concepts, and or maybe it's like policies and details, or policies, business rules, and details. And the core concepts, or the things that the business has to do to turn a profit, are the things that are policies, and they should be ultimately protected from all other systems. Now, when we go to the other end of the spectrum and we get to the main system, or the main component, that is the ultimate detail, because that's the piece of the program that loads every other thing, including our configuration files. So our configuration files get loaded by the main component, and the main component will effectively determine which configuration file is loaded. Maybe it pulls based on environment variables, whatever. Um, it will be the thing that determines which concretions are mapped to which interfaces throughout the system. So every single detail for how the entire program runs lives within the main component. And that's pretty powerful in a lot of ways, because what you can do if you have a highly separated, well architected system is you could create one main component in a single standalone file, like load this, anyways, that loads up all of the things that you need for your production deployment of the website or product or whatever you're building. So you've got your main component that builds that. But this is actually where, to some extent, unit testing comes in, right? Because you could actually have a second component that loads up itself, and instead of pointing to saying, okay, now we're going to set up a web server and we're going to listen for requests coming in, it could say, well, I'm just going to load the class and I'm going to test it to see if things work, right? So a unit test system technically is just running a different main component and using those same shared libraries in a slightly different way, right? Now, let's take this a step further, because we've now established we've got our production system, we've got our testing system, but you could further subdivide that main component at much, much lower cost with a well-architected system to say, maybe we'll run a different version for development staging. Maybe we have a different version for each country that it runs in, or each jurisdiction. So maybe it's right, like maybe it's a voting application that has a fully self-contained executable program for each county that it runs in, right? Or each, maybe you're selling to Fortune 500 and you release one version for Facebook, and you release one version for Google, and you release one version for Pfizer, and each of these ones, since they have their own main component, first of all, it's more than just it just changes the way that the program runs completely and allows for some things to happen in different ways for them. So the main component is the thing that loads all other plugins. It's subtly different from config because it loads the config. You could different main for each country, jurisdiction, customer, whatever. Lots of typos. I don't know if I've mentioned my N key is sticky on this stupid. This is not the freest keyboard that I've ever owned. Not the cheapest keyboard I've ever owned, but N, it works, but you've got to like really press it and wait, whereas everything else is just like touch, type, touch. Anyways, not what we're talking about, but we are at the end of the week, because in terms of the chapter, that was it. I'm not even sure what, that was I don't know, that was useful maybe. I don't know. It just gives you a concept. I think to some extent a lot of what I've done in the past in terms of my training and understanding and how I work through programs is I always worked with things from the perspective, when I'm trying to understand a new program, I say, let me understand the application lifecycle and the request lifecycle. So hopefully, if you're familiar with something called the request lifecycle, it's very specific in a lot of cases to web work, but it's not limited to web. But it's when a web request comes in, what is the first line of code it executes on its way in the front door of your web. So it comes into the web server. Where does that go from there? And then it gets passed on down through the systems, and you kind of want to know what trigger points it crosses over through each step along that path, and then eventually it returns the information. And so that's the question of what the request lifecycle is. Now, the application's lifecycle, in a broader sense, refers to the same thing. You've got your web system running there, but you've got your startup that happens once, right? So I'm starting my application, run all of these startup programs and establish connections and load configurations, and then it handles a whole bunch of requests, and then you have your shutdown protocols here that are separate from all of this stuff. And there can be multiple request life cycles within the scope of an application, but there can only be a single application life cycle. And the point that I'm making here is main is the thing that kicks off the application life cycle versus an individual request life cycle. So that's, I think, useful to think about and useful to talk about, and that's probably why we had that chapter. And I've been live for 36 minutes, and I think I've said everything I need to say for the week, and we'll see you next week. Bye. Which is anticlimactic because I hit my own stop streaming button, but I can do it like this. Bye.